Alright, so in the previous video we were talking about the range and we were talking about the values, right? So variance I was talking about, and this variance thing is pretty I would say it's pretty confusing at times for the people, but I just wanted to give you the definition of this variance, right? So first thing first, the variance is a part of it's a way of measuring the variability. And how do you define? And then the first way of identifying this is range, right? So we talked about range, which is maximum minus minimum, and the second one is called variance. Now what is this variance? Is nothing but the average of the square differences from the mean is called variance. Now how do you say, like you will say like it looks pretty tough, right? Now over here, just look at this value. I want you to just look at this value. This value over here is your mean value, and I will highlight that in yellow mark, right? Just look at this. This is your mean value for this data, and this is also the mean value for your data. So if I wanted to identify the average of the square difference, so how do I find out? For the first value, if I found out the variance of A, probably variance of A would be defined as 45 minus 50, right? And the square of it, right? It's a square of it, right? Plus 50 minus 50, and then you have a square of it. 50 minus 50, then you have square of it, right? And then you say 55 minus 50, and then I've got the square of it, and then you take a mean, like the average of it, right? So how many values you have? You have 3 values over here. Now if you solve this, you will get what? You will get 25 over here, right? So 45 minus 50 is minus 5, and you will say minus 5 square. So maybe I'll just write it down for the first time. I would say minus 5 square, right, plus 0 square plus 5 square, and divided by 3. And this minus 5 square is 25 plus 0 and plus 25 is 50 by 3, which is equals to 50 divided by 3, right? So this is the variance of the data, right, which is the average of the squared difference. This is my squared difference from the mean, right? I wanted to find out like how my data is varying, so that I got to see that 50 by 3 is on an average squared difference of the values which are varying from it, right? Now the variance of B will be equal to variance of B will be equal to, right? So I'll say 0 minus 50. 0 minus 50 is 50 square, right? And I would say 50 minus 50 over here is 0 square, right? And then you have 100 minus 50, which is again, right, it's a 50 square, right? So this is minus 50 square, and then if you calculate that, it will be like 2500 plus divided by 3. This is divided by 3, so 2500 plus 0 plus 2500, which is 5000 divided by 3. So the variance of A is 50 by 3, and the variance of B is called 50 is again 5000 by 3. So this is the difference between the variances of two data set, right? One is A and one is B. I'm taking a small example so that it is easy for you to actually understand. Even if you have like millions of values, this is how the variance will be calculated, okay? So this is one thing, right? Just this one thing, but this variance is good for nothing, right? Because I got to see the squared value of it's a squared differences of the mean value. So what am I going to do is I'm going to delete this I'm going to delete this whole stuff, and I would say over here, I would say the variance of A, I would call it as variance of A was 50 by 3, right? And variance of B, right, I'll just call it variance of B was 5000 by 3, but it doesn't make much sense to me, right? Because I don't know, right, what it is doing, right, for me, right? So what I do is basically I would like to calculate the next level of thing, right, which is called standard deviation. And you must be wondering like why I'm hitting so many values over here, but things will start making sense in a minute, right? So I will say standard deviation over here, right? And what is this standard deviation doing? Standard deviation is nothing but it's a measure of how spread out numbers are, right? How spread out numbers means like how these values are actually varying with respect to each other. So it is represented by sigma, right? This is represented by sigma, and this sigma is your standard deviation, or some people call it at s dot d dot, like this will also do. It's nothing but the square root of variance square. It's a square root of variance square, right? And the formula is very simple. It's a square root of the variance, right? So what is my variance? It's nothing but the square root. So I'll just simply say, and if you notice that this 50 was the squared value, right? So you actually got this value by squaring the things up, and you got this 5000 also, which is by squaring. So if you just take a square, so sigma a would be nothing but the square root of variance of a, and standard deviation of b will be equal to nothing but the variance of b, right? And it will give you the value. So this will be square root of 50 divided by 3, and this would be the square root of 5000 divided by 3, right? So you've got the standard deviation, right? Now because we squared the error up and now we have taken a square root of it, the value becomes the actual average. So it simplifies the whole thing, right? Standard deviation is the measure of how each and every element of the data is away from the mean with respect to each other, right? So if, with respect to mean basically, so if you say 50 by 3, right, this value is representing how there are three elements 1 2 3, how they are away from each other, how much they are away from each other. So there might be some data where you have all the elements which are nearby to each other, and there you might be having some data where all the elements are like quite away from each other, right? And this is actually deciding factor of how your data is shifting. Now what am I going to do is I'm going to draw this for you, and after drawing this probably things will start making much more sense. I'm deleting this whole stuff right over here, and let me draw something for you, right? This is how my data is. Now what am I going to do is I'm going to say, hey, I don't want to keep this part, right? And I don't want to keep this part, right? And just think if I have one value which is say this is 0, this is 0, this is one value, and this is 2 value, and so on and so forth. If I have 0 to 100, right, this is where somewhere we have 50, and this is somewhere we have 45, and this is somewhere we have 55, right? I would say it's 55, right? So one batsman is actually ranging from here to here, and one batsman is ranging from here. Now you can see the graph is little changed. You can see like something like this over here. Probably I can just create one more graph for you. So it will just go to peak till here, and then it will fall down, right? 52, and there's another graph which is going from here to here, right? Here to here. So if you just notice here, right, this is the mean value which is fixed, right? And if you think this is my mean value for both the graphs, this is my mean value, and now what I'm trying to calculate it, that median of this curve and median of this curve are same. Mean of this curve and this curve are same, right? Mean is equals to median, right? This is equals to median, right? So your mean and median are all same, right? The only thing which is varying is the variability, and the variability is something which is very much a deciding factor. So variability for this value is ranging from here to here, and for this guy it is ranging from here to here, right? So I wanted to find out how much on an average point, and both have 3 points, right? So both have 3 points on an average, every element, how they are away with respect to mean, right? How much they are away on an average with respect to mean. So this is what we call as standard deviation. Now apart from that, there are multiple things which are there, which actually helps you identify the standard deviation. And I would like to cover up something called as interquartile range, which is nothing but the way to identify the variability. I'll see in the next video we'll talk about interquartile range as well. And interquartile range is something which will help you identify how your data is distributed with respect to each other, right? And there is a very, very important and very fascinating concept which is coming to your way. I'll see you in the next video.